Hello everyone, welcome back again to A's Data Science. This is the continuation video of week 5 graded assignment for Stats-2. In this video we will cover questions from 11 to 20. If we haven't watched the part 1 yet, then please first go and watch the part 1. So now let us jump on the questions. Let's move towards the question number 11. Okay, so it is given that question number 11 and 12 shares a common data, and that data says that let X follow uniform distribution over the range 0 to 1, and it is a continuous random variable. Define a new random variable as y is equal to minus log x. And the question number 11 asks about the probability density function of new random variable y. Since x follow uniform distribution over the range 0 to 1, so its probability density function will be 1 over its entire range. So we already know how to find the probability of a function that is defined under a random variable whose probability density function is given. What basically we have to do is we have to find fx of x prime and modulus of differentiation of x prime, and then have to multiply the both. The resulting will be equal to probability density function of the new function that is defined under the given random variable. So let us first determine the range of y, because here the y is a logarithmic function of x, so there might be a case where the range may differ from the range of x. When x tends to 0, then y will be equal to minus log of 0, which is equal to positive infinity. When x tends to 1, then y will be equal to minus log of 1, which is equal to 0. Hence the range of y will be y is greater than 0. Let us now find the inverse of y is equal to minus log of x. So this is a basic logarithmic property that if y is equal to minus log of x, then x will be equal to e to the power minus y. As logarithmic function and exponential function are inverse of each other. Let us now find the derivative of inverse. Show the derivative of e to the power minus y is minus e to the power minus y. Let us now find fx of x prime. So fx of x prime will be equal to 1, as fx of x do not have any variable in it. So the probability density function of y will be equal to 1 modulus of minus e to the power minus y, which is equal to e to the power minus y. Hence the probability density function of y is equal to e to the power minus y, where y is greater than 0. Hence the option number 1 is correct. Now the question number 12 asks about the expected value of y. So we just find the probability density function of y, and we know that to find the expectation of a random variable, what we have to do is basically we have to integrate that random variable pdf into variable with respect to dy here over its entire range. So expectation of y will be equal to integrating y into e to the power minus y with respect to dy over the interval 0 to infinity. Hence expectation of y is equal to 1. Let us now move towards the question number 13. Question number 13 basically says that let x be a continuous random variable where it follow uniform distribution over the range 0 to 100, and its probability density function is given below. And if we look at the given probability density function, then the intervals are not clear. There is a variable used in the interval which is represented as a, and it is given that a is between 0 and 100. What value should you choose for a to minimize the expected value of f of x? Given x is a continuous random variable, and x follow uniform over the range 0 to 100. Since x follow uniform over the range 0 to 100, so its f of x will be equal to 1 upon 100. Now let us find its expectation as integrating fx into 1 by 100 over the interval. Since the distribution of interval is unknown by a variable a. So let us break this integral into part at x is equal to a. So expectation of f of x will be equal to integrating to into a minus x into 1 by 100 with respect to dx over the interval o to a plus integrating x minus a into 1 by 100 with respect to dx over the interval a to 100. Now if we solve the first part of the integral, then what we will get is a square by 100. And similarly, if we solve the second integral, then what we will get is 1 by 100 into 100 minus a to the whole square divided by 2. You can pause the video and see the calculation part if you does not able to do by yourself. Now if we add the both integrals to get expectation of f of x, then it will be equal to 3a square plus 10,000 minus 200 times a divided by 200. Let us now minimize the numerator part, as only numerator part have variable a in it. We know that to minimize an equation, what we have to basically do is we have to differentiate the equation and then equate it to 0, later find the value of known. And for that value of known equation will have minimum value. So, first let us find the derivative of 3 times a square minus 200 times a plus 10,000. So it will be equal to 6 times a minus 200. Now if we equate 6 times a minus 200 with 0 and later find the value of a, then the value of a we will obtain is 33.33. Hence, the answer of question number 13 is 33.33. Let us now see the question number 14. Question number 14 says that the probability density function of a continuous random variable x is given and there is an unknown variable in it also. We are asked to find the probability density function of y is equal to 3 times x plus 2. We know how to find the PDF of a variable when it is a function on another variable. What we basically have to do is, we have to find f of x prime into modulus of derivative of x prime. First let us find x prime or inverse of the given y. Since y is equal to 3 times x plus 2, so x will be equal to y minus 2 by 3. Hence, x prime is y minus 2 divided by 3. Now let us first find the unknown value in PDF of x. We know that the total integration of a PDF is equal to 1. So if we integrate the given PDF with unknown and equate it to 0, then the value of unknown will be equal to 3 by 5. Again, if you want to see the calculation part also, then you can pause the video and see it, and still if you can't figure out, then reach me in comment box. Now our PDF of x will be something look like 3 times x by 5 plus 1 by 10. Now let us find the fx of x prime by putting x prime in f of x. The fx of x prime we will get after calculations, and all is 2 times y minus 3 divided by 10. Now let us find the derivative of x prime. Derivative of x prime will be equal to 1 by 3. Now if we multiply both values of fx of x prime and modulus of derivative of x prime, then we will get our PDF of y, which is going to be equal to 1 by 3 into 2 times y minus 3 by 10, which is equal to 2 times y minus 3 by 30. Let us see the range of y now. Since y is equal to 3 times x plus 2 and range of x is 1 to 2, then range of y will be also 5 to 8, which is basically 3 times old range of x plus 2. Now if y of y is equal to 2 times y minus 3 divided by 30 and the range of y is 5 to 8. Hence the option. Now let us move towards the question number 15. Question number 15 basically asks that find the expectation of y. Okay, so first of all, this is the continuation question of previous question. In the previous question we already find the PDF of y. And we know how to find the expectation of a continuous random variable. So here expectation of y will be equal to integrating fy of y with respect dy. But if you look at the probability density function of y, then we can make assumption in our mind that integration of that PDF will be quite tougher. So there is one more easiest method to do this, is that we can find the expectation of x, and later since y is given as 3 times x plus 2. So expectation of y will be equal to 3 times expectation of x plus 2. So if we find the expectation of x, then the value that we are going to get is 1.55. Now expectation of y will be 3 into 1.55 plus 2, which is 6.65. Hence the expectation of y is 6.65. Let us now move towards the question number 16. Question number 16 basically says that in a university, 30% of the students enrolled in math course are from science stream and 70% are from the commerce stream. Exam score for the science stream student follow a normal distribution with the parameters 55 and 36. And for commerce student, it also follow the normal distribution with the parameters 60 and 25. If a randomly selected student scored 60 in the exam, what is the probability that the student is from the commerce stream? Given probability of student is from science stream is 0.3 and student is from commerce stream is 0.7. We are asked to find the probability of student is from commerce stream under the condition it scored 60 marks. So again, after using the Bayes theorem on our conditional probability is going to be something look like this one. And now again, since both the distribution is following the normal distribution, we will again use the Gaussian probability density function to find each conditional probability, and later we will put this value in our required Bayes equation. So the probability of x is equal to 60 under the condition it is from sine stream is equal to 1 by 6 times root under 2 pi into exponential of minus 25 by 72. And similarly, the probability of x is equal to 60 under the condition it is from the comma stream is equal to 1 by 5 times root under 2 pi. Now if we put these values in the Bayes theorem and find the probability of a comma student under the condition it scores 60 marks, then it will be equal to 0.80. Again, you can pause the video and see the calculation part if you need. Hence the answer of question number 16 is 0.80. Let us now move towards the question number 17. Question number 17 says that a company produced 3 types of widget, type A, type B, type C. The production cost of a widget depends on 2 independent random variables: machine efficiency M and raw material Q. Machine efficiency follow uniform distribution over the range 1, 2 and 3. Raw material quality follow the normal distribution with the parameter 4 and 1. The production cost is given by the formula C is equal to M times Q plus M. If a random widget has a production cost of 12, what is the probability that the machine efficiency M was 2? So basically here we have to find probability of M is equal to 2 under the condition C is equal to 12. Now again, if we use Bayes' theorem on this conditional probability, then our conditional probability will now something look like this one. Given C is equal to M times Q plus M, which will be equal to M times Q plus 1. Since Q follow the normal distribution with the parameter 4 and 1, so its density at fixed Q will be something look like this one. Now since M follow the uniform distribution over the range 1, 2 and 3, so the probability of M is equal to 2 is going to be 1 by 3. Let us now find the probability of C is equal to 12 under the condition M is equal to 2. First, let us find its value of Q using the formula of total production, which is Cm times Q plus 1. Here our C is 12 and M is 2. After putting these value in formula of total production, the value of Q for probability of C is equal to 12 under the condition M is equal to 2 will be 5. Now if we use this value of Q and find the probability of C is equal to 12 under the condition M is equal to 2, then it will be equal to exponential of minus 1 by 2. We are skipping the constant part here in all the cases because the constant part will be going to cancel out from the both numerator and denominator part. And similarly, probability of C is equal to 12 under the condition M is equal to 1. After finding its value of Q using total production formula, it will be equal to exponential of minus 49 by 2. And similarly, probability of X is equal to 12 under the condition M is equal to 3. After finding its value of Q using total production formula, it will be equal to exponential of minus 1 by 2. Now if we look at the option B, then the value associated with each exponential in option B is same as the value that we are obtained. Hence option B is going to be the correct option for the question number 17. Let us now see the question number 18. Question number 18 basically says that a bakery produced 2 types of cake, chocolate and vanilla, where weight of chocolate follow the normal distribution with its parameters as 4 and 100. And weight of vanilla follow uniform distribution with the range 5 to 15. And we asked to find the probability of chocolate cake under the condition weight is 4 kg. So if we use the Bayes theorem on the conditional probability of chocolate cake under the condition weight is equal to 4 kg, then it will be equal to probability of weight is equal to 4 kg under the condition it is a chocolate cake into probability of chocolate cake by the probability of weight 4 kg under the condition it is chocolate cake into probability of chocolate cake probability of weight is equal to 4 kg under the condition it is a vanilla cake into probability of vanilla cake. Now if we look at the distribution of weight of vanilla cake, then it follow the normal distribution with the range 5 kg to 15 kg. It means that vanilla cake of 4 kg is not possible as 4 is not in the range of its distribution. Hence the probability of weight is equal to 4 kg under the condition it is vanilla cake is equal to 0. That resulting the probability of chocolate cake under the condition weight is equal to 4 is equal to 1. Hence the answer of question. Let us now move towards the question number 19. Question number 19 basically says that An online education platform conducted a study to analyze the user engagement patterns. It observed that 70% of its users are regular learners, while the remaining 30% are occasional learners. The duration of the time spent per session in minutes follows a uniform distribution over the range 40 to 90. Distribution for regular learners and a uniform distribution over the range 20 to 60. If a randomly selected user is observed to have spent 50 minutes in a session, what is the probability that this user is a regular learner? We are given with probability of regular student is 0.7 and probability of occasional student are 0.3. Both the distribution of time spent by both regular and occasional student follow the normal distributions with their respective ranges. We need to find the probability of a regular student under the condition time spent is 50 minutes. So again, let us use the Bayes theorem on this conditional probability, and after using the Bayes theorem, the conditional probability will be something look like this one. Since time spent by the regular students follow the normal distribution over the range 40 to 90, so its probability density function will be going to 1 upon 50. And similarly, the probability density function of occasional student will be equal to 1 by 40. Now, if we plug in the required value in the Bayes equation of the conditional probability, and later if we solve the equation, then the conditional probability that it is a regular student under the condition the time spent is 50 minutes will be equal to 0.651. Hence the answer of question number 19 is 0.651. Let us now see the last question, which is question number 20. Question number 20 says that a logistics company monitors the delivery time X in hours of same-day intracity shipments. The delivery time follows the probability density function which is given below. The delivery cost for a shipment delivered in time X is modeled as C of X is equal to 100 times X square plus 100 into 1 minus X. Find the probability that the delivery cost exceeds 100. Here we basically have to find the probability of Cx greater than 100. First, let us see for what value of x, Cx is going to be greater than 100. So, 100 times x square plus 100 times 1 minus x greater than 100. From here, if we solve for x, then the x that we are going to get is x is greater than 1. Now it means that we have to find the probability density function over the range 1, 2, 3. So probability of x greater than 1 will be equal to integrating to by 9 into 3 minus x with respect to dx over the range 1, 2, 3. If we solve this integration, then the probability of x greater than 1 will be equal to 0.44. Again, if you felt any trouble in solving the integration, then you can pause the video and see the calculations. Hence the answer of question number 20 is 0.44. Okay, so that is it for graded assignment of week 5 for Stats-2. I hope you all learned something from this video. If you do, then please don't forget to show you love, as it take a lot of efforts to create the videos.